of you seen on Twitter, but I will raffle a Chromebook for you. I'll just share the rules to be part of the raffle. Okay, so just grab your seat and we'll start. By the way, many people ask me, what about these slides? These slides are freely available at this URL, okay? bit.ly/Red Hat MSA, MSA of Microservices Architecture, so it's easy to remember. And these slides are always being constantly updating, so just get this URL and you can think like free open source slides, okay? So let's start, because we have a lot of content to cover in less than 1 hour. Okay? So my name is Rafael Benevides. I work for Red Hat as a director of developer experience. But essentially, I'm a Java developer. Okay? Something that I like to do in my free time is to build and fly my own drones. Okay? And some people ask me, why do you prefer to build your drone instead of just buying one? I like to say that's just like, by the way, you can just take a seat. There are some empty seats here and there and there. Okay. I like to say that's more or less like building your gamer PC, that you can choose the graphics card and memory and hard drive, and buying a laptop. When you build something on your own, just like a drone, you can choose. You have the freedom to choose the propeller, the battery size, the flight controller, the receiver. And if I bought a new one, I have everything in one place. It's good, but here I have the freedom. And with microservice, it's more or less like the same. With microservice, I have the freedom to choose the best technology, to choose between Java and Node and Go. But with microservice, it's even better, because here I cannot change the motor while I'm flying. With microservice, I can do that on production while everybody's accessing it. And we will see that in a demo. Okay? So before starting talking about the microservice and how you cannot fail at microservice, I like to invite everyone here to join the Red Hat Developers Program, because there you can find nice and free resources for you as a developer. You can find free resources like blog posts, webinars, free ebooks, just like this one, Microservices for Java Developers. By the way, I'm releasing the 2nd edition this year. Building reactive microservices in Java, migrating to microservice database, introducing Istio Service Mesh for microservice. By the way, how many of you is a Java developer? Oh, everyone. So have you heard about the microprofile specification, right? So I need to talk about that to you. And of course, who have seen the talk about Quarkus from Peter Palaga yesterday? Okay, for those who have not raised your hands, let me just give you an idea how Quarkus is so nice, because we are all Java developers here, right? So let me increase the font size so you can all see. And let me go to the downloads page and start a new project from the scratch. I will call it Hello World Hello World 2, because I have a Hello World in this directory. Okay. Yeah, I was trying to make my creativity as best as I could. So it's an empty project. I will not create any code, because I want to focus on microservice, but I just want to give you an idea. I'll do a Maven package. Whoops, Maven package. Just a regular Maven project. It will run the test before creating the final project. And now, inside my target folder, I can do a java-jar and execute hello world 2 runner, which is a fat jar. And look here. It started in half second. And the question, does it work? Yeah, if you go to localhost, and it's working. You can even go to hello, and it's there. It's working pretty fast. And the question also is, how small or not is this jar file? So let me get here, hello world. The runner is 34K. Let me execute it again, and let's see how much memory it fills. So it occupies less than 100. So it's changing the Java world. So that's why I wanted to share that to all of you that were not in the yesterday session from Peter Palaga. OK, now let's talk about microservices. By the way, the rules to get the Chromebook is, it's not Vert.x, it's, yeah, Voxed, days, book. Let me see, is that, Twitter. Let me get the proper hashtag. Voxed days. Oh, Can you just spell to me? It's VXDBUH19, right? It's without VDBUH19. OK, now. So what you need to do to win the Chromebook? You need to follow me on Twitter, take a picture of the session anytime, mention that you are here with, and mention my name, and with the hashtag VoxDayBookRest19, VDBHUH. And then I will run an application that will get all these tweeters using the hashtag, of course, with the picture, and then I will choose one. Oh, no, I mean, the application will choose one. OK, so finally. OK, finally, about microservice. You are not going to use microservice because it's cool or because it's easy to develop, easy to maintain, right? Because, in fact, it's really hard to produce microservice. It's hard to develop a microservice application. It's hard to deploy. It's hard to maintain. So the only reason to use microservice is this word here. It's all about agility. OK? When I started talking about microservice 2 years ago, the X was there, the peak of inflated expectations. Now people have tried microservice. They see that probably it's not for them. So they are going to the throw of disillusionment. Probably there will be a time when they will learn with their experience. They will improve their culture. And then there will be an enlightenment. And become probably microservices can become a mainstream. We don't know. We are talking about the future. And of course, when we are talking about microservice, there are two realities. There is the reality of a greenfield, nothing has built on top of it, just like a startup, or a brownfield, where we have companies that are producing applications for 5, 10, 15 years. But no matter if we are talking about our startup or an enterprise company, both of them need to go through a kind of evolutionary process, where the first step of this evolution is to reorganize your team to adopt DevOps practices. Okay? The next step of the evolution is to have a self-service, on-demand Elastic infrastructure. Because with self-service, on-demand Elastic infrastructure, with DevOps practices, you can start having automation, and not only about automation of the build, but automation of the infrastructure, using tools like Puppet, Chef, Ansible. And then you can have a CI/CD deployment pipeline. With all those things in place, including the CI/CD deployment pipeline, you can have advanced deployment techniques, like blue-green deployment, rolling deployment, canary deployments. We'll see some of them here on a demo. By the way, keep your cell phone with you. Keep your mobile in your hands, because you will be part of the demo. Okay, I will have a microservice application that I want you to access and try it. And then, who knows, you can become a next Silicon Valley unicorn, having your first microservice. All those things here were not from my head. They came from this article from Martin Fowler. Martin Fowler said about the self-service on-demand Elastic infrastructure. He said about the DevOps practices. He said about automation, CI/CD, deployment pipeline. So yeah, it's fundamented. Now let's play a game. Imagine that everyone here will produce a microservice. So everyone here needs to agree what is the operational system that we will use. We will use Windows, Mac, Linux. What Linux distribution? What version? Okay. Now that we are all Java developers here, what Java virtual machine will we use? What JVM? Is it JVM 8, 10, 11, 12 that was just released? Yeah, probably. Who knows? But everyone needs to agree on that. And then we need to choose what application server we will use. And then inside our application server, we start to produce our ER enterprise archive. Then we place our WAR files inside of it. To avoid the duplication of code, we start extracting jar files. And then with a common code, we start producing more WAR files. And things start to grow and grow. And when you realize you have a wild beast to maintain and deploy. So probably in this group, or to maintain this wild beast, we need programmers, we need DBAs, we need business analysts, we need people from testing, from operations. I don't know if we have everyone in these roles here, but we need those kind of roles to maintain this wild beast. But we can have this big team, but the reality is that this huge block, this huge monolith, will be spread on modules. So probably we'll form a team that will take care about security. Another team will take care about the finance. Another team will take care about sales. Another team will take care about the warehouse. Depends of the kind of the application that we will produce. But again, using the same operational system, same JVM, same application servers, same Git repo. Okay, so imagine that we receive a request to produce a feature. Okay, and let's be honest. No matter if you have the latest and the coolest technology running on your laptop, for the customer or for the company, it doesn't have any value. It needs to be there on production to have a value to the customer or to your company. Otherwise, it's just a proof of concept on your laptop. No value. So, sometimes to specify, implement, test, approve, and place a code on production, usually it can take like 24 weeks. Of course, you can adopt some practice to reduce the time. For example, you can get use automated testing and reduce that to 12 weeks. You can adopt automation, infrastructure as a code, and reduce the time. You can adopt continuous delivery pipeline. You can adopt zero downtime deployment strategies, and that can reduce the time. In a high-trust environment, maybe you can deploy once a week, but the question is, how can you deploy faster than a 3-week sprint cycle? Because usually a sprint, agile methodology like Scrum, a sprint is 3 weeks. There's a book called The Phoenix Project that mentions 10 deploys a day. This book is a novel. It's not a technical book where you learn how to program. It's just a novel that tells a story that a guy who was hired in a very in an environment that was so bad that everything was not working, and then he started to implement some techniques, and finally everything, after different tries, the environment was so evolved that he could do 10 deploys a day. And how is that possible? The only way to do 10 deploys a day is breaking up your monolith in small pieces. Because on the first week, you can deploy the part A, C, and D. The next week, you can deploy another version of A, H, and G. The week 3, you can deploy B, F, I, J, and another version, another update of A. So yeah, when you break up your monolith in smaller pieces, you are achieving agility. Remember, the only reason to use microservice is because you want to have agility. So suppose that we are here, we decided to create a microservice. This team here can choose to use Spring Boot with Postgres. This team here decide, you who said Java 12, yes, you, you, will implement using Quarkus with Java 12. Another team can use just microprofile using Thorntail and MySQL. Another team there probably is not a Java, they are not Java developers, they choose to use Node.js. So that's the point. You can choose the best technology for that use case. And they're not, you can deploy at any moment. But every time that we're talking about microservice, we need to remember about Conway's law. It says, if the communication infrastructure of this team, of your company, it's good, probably the application produced will be good as well, because it tends to be a copy of each other. So before starting to produce a microservice application, we need to have a better a good automation, a good communication structure here. We need to have that well defined. Okay, most of you who have seen this kind of organization here can say, okay, I know how to integrate all those things. It's easy. Just place enterprise service bus, and we are good to go, right? I see some odd face like, ah. And the problem is, ESB is not it's based on SOA architectures. And SOA architectures are not microservices, and microservices are not SOA architectures. They are totally different. Okay? When you have SOA architecture, the enterprise service bus is smart, and the pipeline and the endpoints are dumb. So we have smart pipeline and dumb endpoints. In microservice, it's the opposite. You have a smart endpoint and dumb pipelines. The enterprise service bus, the pipeline was smart because it needed to locate, transform, and route the content. Okay, in microservice, you don't need that. But SOA is not that. You can use SOA nowadays, but to integrate different applications. When we are talking about microservice, we are talking about one single application divided in small modules. Okay? And when I talk about smart endpoints and dump pipelines, it gives gives to the developer great power, and we can't forget about Spider-Man. With great power comes great responsibility. Okay, and we'll see that later when I'll talk about patterns, microservice patterns. Okay, so let's recap some microservice principles. The first one is deployment independence. We need to be able to deploy independently. And that will create a distributed computing. We'll have microservice A calling microservice B. And because of that, we need to focus on the API. The API needs to be very clear in a way that I will change only the implementation. But what if I need to change the API also? We need evolutionary design. A great example of evolutionary design is Kubernetes. Kubernetes is at this moment on the version 1 dot something. But Kubernetes is prepared for Kubernetes 2, because nowadays we have in the YAML file the version specified on the YAML. So if Kubernetes gets the version 2, probably when you send a version 1 file, it will transform that to a version 1 and do from 2, something like that. It needs also to have a decentralized data management. What does it mean? It does mean that if you have 100 microservices, very likely you will have 100 database. That can be odd, right? Especially for DBAs. DBAs will say that will break your integrity. You are breaking all the rules of database. And we talked about smart endpoints and dump pipes. And in that case, the DBA can hunt you and try to kill you. So probably you can give him this book and say, no, we are friends. Or you can also give him the book from Edson that you can get for free at Red Hat Developers, migrating to microservice database. Okay, now let's see a demo that shows some concepts of microservice. Okay, you can access the front-end application in this URL here, frontend-hello-world-msa.app.rafabene.com. Okay, I will give you a moment so you can try this URL. Because inside this application, there is a hello world, and you can see, oh, come on, hello world. But I bet you that it's the best hello world that you will ever see. Okay, let's see why. Because here in the Git repo, I have different microservices. They all say hello in different languages. I have hello in Spanish that's implemented using microprofile. I have hello in Portuguese that's implemented using Spring Boot. I have hello in French using Node.js. I have hello in Hawaiian using Vert.x. And I got all these microservices and deployed it on my Kubernetes/OpenShift cluster. So you can see Aloha here, you can see Bonjour, you can see Hola in Portuguese and Spanish, and you have also the front end that you can open here. Again, front-end-hello world-msa.app.rafabene.com. Okay, let me. Okay. Let's continue. No matter what language you decided to use microservice, we need some kind of properties, right? The first one is and what we will do now is go through each one of these properties, and we will see how it works on a microservice, what you should do and what you should not. So the first one is the API. The API, it's easy, right? We need to write an API. Different technologies offers different approaches. So for Java EE, we have JAX-RS. For Spring, we have Spring MVC. Vert.x has web router. Node.js has Express. That's easy, right? So let's see the API of this microservice here. So if I invoke here bonjour, and I get api.bonjour, so this is the URL. It's a REST endpoint that will reply bonjour. So I'm refreshing here. It's always, I have just one replica of this microservice, so it replies hello from and the name of the container. So that's easy, really, really, really easy. Now, for discovery, for many years during 2014, 15, people used Netflix, Eureka, and Ribbon to find for service A to call service B. In a new world, we use Kubernetes. If you deploy everything inside Kubernetes, you can do, for example, let me open a terminal inside a container. So I have a terminal here. I'm inside bonjour. I can do ping hola. That will reply a cluster IP. Or ping aloha. That's another IP. So Kubernetes has internal DNS to resolve the name of the microservice. So you don't need Eureka, you don't need Ribbon. You just need Kubernetes when you deploy containers inside the Kubernetes cluster. Okay, now let's see some patterns. Remember that I said one of the parts of the evolution process. No, that's later. So yeah, one of the first patterns is to have the browser as a client. So imagine a screen like that, just like Amazon, just like a regular web store. Each part of the screen will come from a different microservice. So we have the price coming from the price engine, the reviews, the details, specification. Look here, location-based availability. I know that there are 15 notebooks on Raleigh Central Avenue, store 1123. But what happens if this microservice is not available? We are talking about distributed computing. So many things can go wrong. This service cannot be available. And in this case, another concept of microservice is that you need to provide a fallback. So if this service is not available, I will not give a blue screen or say something went wrong, try later. We'll start to lose customers because of that. So we can provide a fallback where I'm running inside a mobile device. I can use the GPS, and you don't know how many laptops there are on that store, but you can use the GPS and show where is the closest store. And the customer can go there, and the application is available, and that's okay. Then the sales guy can say, okay, I will order one to you and deliver to your home. But you hold the customer. You don't lose the customer to a competitor. It's just a, yeah. It depends. For picky customers like you. Okay, so API gateway. Some people think the purpose of API gateway is to have a single point of entry that will locate and invoke the microservice. Some microservice probably, if you have a messaging microservice that does not allow you to access through HTTP. So the API gateway can also translate from one protocol to another. And also, the API gateway can handle any failure. Okay? Some people think, what is an API gateway? It's something that I can buy from another, from a company. No, it's just another microservice, but that does not handle business. It handles only communication. And of course, you can have a chained invocation because it's micro. Probably a microservice needs to call another microservice that will call another microservice to handle a use case. But there's a problem here. What something on the middle of the chain fails? We don't want to have a cascading failure. So the previous microservice has to be smart enough to decide, will it call another microservice or not, what it will do. That's why the developer has a lot of power. That's why we need to have great responsibility. Okay? And of course, you can mix all those invocations. So, if we go to our backend, we'll see them here. We'll see the browser as a client. I can even open the inspect here, network, and invoke. I will see that each microservice is being invoked. I can see the this is the chaining. I can see the result of each microservice. Okay, then it gets the result and right here on the screen. Or you can have the API gateway pattern. The API gateway in this case, I used Apache Camel because Apache Camel is really nice to integrate for integration. So I used Apache Camel to collect the result. And in this case, not the source, but if I invoke here, I have only a single result from everyone coming from the API gateway. It collects everything, creates an array of string, and write to the screen. Or I can have a service chaining. Okay, the same thing. It's also an array of strings. Oops. That will give the result. Of course, since we are talking about elasticity, with elasticity, I can also increase the number of replicas. So the number of alohas, for example, I can have 3 of them. And then when they are running, if I invoke aloha, let me see. Yeah, now I have 3, more than 1 replica. Let me just write a while true. Let me use this URL here. And now you can see different 3 containers responding for that microservice. Okay, because that's elasticity. I grill the number of replicas based on my demand. If there's no need to have 3 replicas, I can shrink that to 1. Okay. Another example is related. Another thing that we need to have in our microservice is circuit breaker, related to resilience, right? Imagine that a service A is calling service B, and the service B is slow to respond. What our users will do? Refresh, 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 refresh 1,000 times. What will happen? Service A will open a thread, try to communicate with service B, and that thread will be in a wait state. Service B will become slower because it is already slow, and we need to serve more requests. And service A will start to get slower as well because there will be hundreds of threads in a wait state. So there will be a general degradation. So we need to fail fast. If the service B is slow or is giving an error, I can just open the circuit and say, OK, it's not available. And here is the place to provide a fallback. So if in this case, I implemented the response to just say fallback. So let me just show that. By the way, something that I would also like to show is because here I used Histrix. Histrix allows me to have a dashboard where I can see the details of the invocation. So for each microservice, I know how many requests were made, the average response time, the volume, the status of the circuit, if the circuit's closed or open. So let's see that working. I will open here the dashboard. So let me go to the overview. Let me open the Histrix dashboard. Okay. You can see the status of the microservice here. And now you can start playing with your mobile device. You will see that the number of requests here will increase. I'll do that together with you. So I'll get the service chaining and start refreshing the results. So you can see that the volume here started to grow, right? It's everything working, everything green, everything perfect. We can see a lot of requests coming. But I will do something now. I will stop the Hola service. So let me stop the service called Hola. And scale to 0. You can now see that's red. And something that's really nice is because if I access that, you see that the circuit's opened. And it's failing fast. There is no timeout. Because if the service was slow, it will enter on a wait state. It will be there, waiting for the response and then get the response. Now it's failing fast, just like that. Because you are trying with me, and if you see here in blue, short circuit, so all the requests here are being short-circuited. So that's an example of circuit breaker and how you can have resilience with your microservice. Remember that I said that this is a cool hello world example? I bet that it was... The microservice was just hello, but the things that you can do are really nice. OK, so regarding to authentication, every microservice needs to authenticate. No, not every, but some. Let's get here, for example, the first tab where it says using SSO client. If I try to access the microservice, here it's just some of them are given unauthorized. OK, so I need to be authorized. I'm not authenticated. What I will do now is click on the login. And of course, I don't want to have a login screen for each microservice. I need to have a single sign-on that will propagate the credentials to all microservices. In this case, I'm using Keycloak. So when I click login, the web service will redirect me to Keycloak to get the credentials. But looks something that's amazing. And I will need your help also. Let me get to click Keycloak and open the Keycloak admin console. And let me log in. Hard password, admin. And for this screen here, I didn't write a single line of code. OK? How is that possible? Because Keycloak, I can customize the login screen. So suppose that I want to enable forget password. I can just refresh. Now I have forget password. Or if I want to remember me, save. Remember me is there. It's just customizable. But I can also integrate with different identity providers like Twitter, Facebook, GitLab, LinkedIn, Instagram. I have one configured here to use GitHub that I will just enable. And if you go to this screen, you can see GitHub. So it's easy to have authentication with your microservice. Now, I will log in with GitHub because that's easy. You can try also. And it will go to GitHub, get your username, authenticate you, and fill with your credentials. Now I can try the microservice, and I will see here that I have, this is a security resource. You are logged in as Rafael Benevides. This one here is failing, just ignore. But here I have unauthorized. Why is that? Because here I just need authentication. And here I need authorization. So I can go to my user list, view all users. I can, oh, by the way, I can see that some people tried. Florin Manila have tried. Hello, yeah. So I'll be nice with you. I'll go to, see, I just have your email, a name, but I don't have your password. That's with GitHub, okay? But what I will do is give you the role users. So now you will be able to access that, that resource. Oh, we have also another friend here, Gabriel. Gabriel, I will be nice with you. I will also give you the user's role. And, of course, with myself, so I can show to you, I will give the the user's role to myself. Now, if I log out and log in again, Keycloak will match my username with the roles. And now I have the role users. I can refresh the result, and now I can access. Probably you can access as now if you log out and log in again. Okay, Gabriel? Oh, thank you for help me testing that. Okay, so that's an example of authentication and how you can perform authentication. You can, since we are talking about distributed computing, it's good to have an aggregated login mechanism because we have login spread all over the place. So we need a stack, and the suggested stack is EFK, Elasticsearch, FluentD, and Kibana. We need to have monitoring, okay, like Hipster, Hawkler, and Cassandra. And we need also tracing. Tracing for one of the first implementations of distributed tracing was Zipkin. But now we have the open tracing specification, and they have Jagger as an open tracing implementation. So let me show how that works here. Where is the front end? Oh, I've closed the front end. So if I open the Jagger dashboard, go, 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 go. I can see all the, for example, I want to see everything that invoked bonjour. I can see over the time. I can see some requests here. I can see that bonjour, in this specific span, it was accessed by the API gateway. So there was an error here, accessing what service? The HOLA, that moment that I turned off. So I can see visually that the API gateway had a failure here. I can see the dependencies, and that the API gateway called the microservice, and this is the service chaining. So this is one example of distributed tracing. Okay. So distributed tracing is really nice. Okay, now really, we need to go fast because our time is almost over. Advanced deployment techniques. Blue-green deployment is when you place your code on an environment, on a parallel environment, and you go to the router and just change the rule. Send the traffic to that version. If something goes wrong, you just flip to another version. So let's see that. I have two implementations here of API Gateway. I have API Gateway and API Gateway Blue. I can go to the route, get the API Gateway, and say, now I want to send every traffic from the API Gateway to API Gateway Blue. So let's see what's the behavior. If I click refresh, I can see that it has been updated. If I want to return to the previous version, it's easy. I can come here, save the route, and by the way, you can try. Of course, if you try now, you'll see the full response. Okay, you can also have canary deployments. By the way, canary deployments is when you have a small portion, a small version that goes to the production, and you start to send requests to that version. And when the number of requests, if the canary doesn't die, you can increase the number of requests until it becomes 100%. So let me do that here. I have a pipeline defined, and I will start a pipeline here. This is one I have tried before. And this pipeline is integrated with Jenkins. So it's a customized Jenkins instance. By the way, this is not admin. So let me open the Jenkins console. You can see that Jenkins will create a slave container to run the build. And when it's running, it will start to move the pipeline according to what? According, let me go here to pipeline, configuration, according to this Jenkins file. So here inside my microservice, I defined all the steps to build this microservice. I defined that it will do a Maven build, then it will create an image, run the automated tests, and that's really important. When we are talking about pipelines, we must have a good battery of tests. Why? Because the tests need to prove that candidate release is unreleasable. Why? Because we don't want to automate the introduction of bugs on production. It's simple. So we need to try really hard and make sure that the application is good to be promoted to a quality assurance. In this case, I don't want automatic approval. I want a manual approval to send the code to production. So here we have the pipeline running. It's building the image on the development. We can see the log here. So it ran the tests. It's running the test, right? So it survived the test, so it can continue working and go into the next stage. So it promoted the image to the quality assurance area. And now with the quality assurance area, I can, for example, let me duplicate that, open the quality assurance project. I can see my microservice there that's rolling the deployment. I can open the microservice. In the microservice here, I have a Swagger. I can try and see if it's running okay. Okay, it's perfect. By the way, look here. This microservice has a typo. It says Aloha. In the quality assurance, it says Aloha. So it was fixed. Now I can see here, it's waiting for approval. I can approve and send to production. So the script will continue and perform a canary deployment. So look here, in a couple of seconds, there will be another version here with 0 downtime. Oops, let me see, yeah. Aloha, so it's performing a canary deployment. And here we have Aloha. So we have a small version of the microservice that's correct. And I can control that by stopping the number of replicas of the previous version. And if I scale that to 0, we will see just Aloha responding. Let me stop, run again. Yeah, just Aloha is responding. Okay, since we are out of time, I just want to give you right on time. This idea here, that's also from Martin Fowler. If you want to produce microservice, go to monolithic application first. Because if you go straight to a microservice architecture, you will find dragons and lizards, and you'll have a lot of trouble. First, produce your monolith. Then, as the complexity increase, then you can have your first microservice that will allow you to have all the culture, all the technologies, all the things needed to have one microservice. Then you can continue breaking out. Okay? So thank you so much. I'll do the raffle now. And let's wait for the winner. Thank you.